Welcome to our latest video where we explore one of the most critical yet smallest spaces aboard an aircraft carrier, the Integrated Catapult Control Station, also known as the bubble. This tiny room on the flight deck is where the magic happens, enabling the awe-inspiring capability of launching and landing jets in rapid succession. In the bustling environment of an aircraft carrier's flight deck, amidst the roar of jet engines and the orchestrated movement of crew and machines, sits a remarkably small yet vitally important room known as the bubble. Officially termed the Integrated Catapult Control Station, ICCS, this compact space is crucial to the ship's operation, primarily focusing on the launch mechanisms that propel aircraft into the sky. The bubble is not just a room with a view, it is the epicenter of flight deck operations. Positioned strategically to oversee the entire flight deck, the bubble provides officers with an unobstructed view of takeoffs and landings. This placement is critical for managing the precise and safe launching of aircraft, which occurs within the confined space of the carrier. The visibility and central location facilitate immediate response to any operational necessities or emergencies. Equipped with state-of-the-art technology, the bubble integrates various control systems that were traditionally scattered across multiple stations on the ship. This consolidation into a single control station significantly enhances operational efficiency and reduces the potential for error, a key factor in high-stakes military operations where every second counts. Inside the bubble, officers control the catapult systems that launch the aircraft, using a series of levers, buttons, and digital displays that feed real-time information about wind speeds, aircraft weight, and other critical variables. The design of the ICCS is a testament to modern naval engineering, focusing on both safety and efficiency. The bubble's advanced systems help to eradicate the need for several remote stations, streamlining communications and reducing the chances of miscommunication during critical takeoff and landing phases. Enhanced safety features within the bubble allow officers to quickly address any issues that arise, ensuring that each launch is conducted under the safest conditions possible. The bubble's role extends beyond mere observation and control. It is a dynamic command center where crucial decisions are made. The officers stationed inside are not only responsible for the mechanics of launching aircraft, but also play a key role in strategic decision-making that affects naval operations at large. Their ability to monitor and react to situations in real time is crucial for maintaining the operational tempo necessary for mission success. The bubble, while physically small, plays a disproportionately large role in the safe and efficient operation of an aircraft carrier's flight deck. Officers stationed within this Integrated Catapult Control Station, ICCS, are tasked with a range of critical responsibilities that require a high degree of precision, vigilance, and expertise. Here we delve deeper into the roles these officers play, underscoring the importance of their duties and the impact they have on naval operations. Before any aircraft can be catapulted into the skies, a series of rigorous safety checks are conducted from within the bubble. These include environmental assessments. Officers must assess wind speeds and directions, as these factors critically influence the launch process. Safe launches require specific wind conditions, and any deviation from these can delay operations. Flight deck monitoring. The bubble provides a clear view of the flight deck, allowing officers to ensure that all personnel are clear from danger zones and that the deck is free of debris or any other hazards that could impede a safe launch. Aircraft readiness. The readiness of each aircraft for launch is confirmed, including checks on the positioning of the aircraft, the status of its engines, and the proper configuration of its systems for flight. A crucial aspect of operations within the bubble is maintaining clear and constant communication with both pilots and deck crew. This communication is vital to coordinate the timing of launches and to manage any last-minute adjustments or aborts. Visual and signal communications. Officers use hand signals, lights, and other visual cues to communicate with pilots and deck personnel. This is especially critical in noisy environments where verbal communication might be impaired. Response to pilot signals. Just before takeoff, the officer in the bubble must pay close attention to the pilot. Any head movements or changes in cockpit lights can signal a need to delay the launch, indicating perhaps a last-minute technical issue or a change in mission parameters. The officer in the bubble also acts as a command point, making decisions that affect the immediate actions on the flight deck. Launch authorization. Once all systems are checked and clearances confirmed, the officer in the bubble authorizes the launch. This decision is based on a comprehensive assessment of all factors, including aircraft status, environmental conditions, and deck safety. Emergency decisions. In the event of an emergency or anomaly during the countdown to launch, the officer in the bubble has the authority to abort the takeoff. This decision must be made swiftly to ensure the safety of the crew and the aircraft. After an aircraft has been launched, the responsibilities of the bubble officer do not end. Post-launch monitoring is crucial to ensure that no debris or damage on the deck could affect subsequent operations. Review and reset. The officer reviews the status of the catapult and deck to ensure everything is reset and ready for the next launch. This includes checking that all systems return to normal operational status and that the deck is once again clear of any obstacles. Within the confines of the bubble, the Integrated Catapult Control Station, ICCS, stands as a pinnacle of naval engineering, orchestrating the precise and rapid launch of aircraft from the deck of an aircraft carrier. This segment delves into the complexities of the ICCS, detailing how it controls the catapult systems and manages the operational dynamics involved in aircraft launches. The ICCS is a highly specialized and technical setup designed to maximize efficiency and safety during flight operations. It includes several key components. Catapult Officer Control Console. This is the main control hub where the catapult officer oversees the entire launch process. The console is equipped with multiple input devices and displays, providing real-time data on each phase of the catapult operation. Monitor Control Console. Adjacent to the catapult officer's console, this system monitors the status of the catapult mechanisms and the readiness of aircraft. It provides continuous feedback and system statuses to ensure that all components are functioning within their operational parameters. Central Charging Panel. Located below the deck, this panel controls the power and energy systems that drive the catapults. It is crucial for preparing and resetting the catapult systems between launches. The ICCS integrates these components into a cohesive workflow that enhances the control and safety of aircraft launches. Controlled workflow. The design of the ICCS allows for a smooth workflow, where commands and data flow seamlessly between the consoles and the central charging panel. This integration ensures that all systems are synchronized and that the catapult officer has control over every aspect of the launch. Distributed controls. The ICCS distributes control between the deck and below-deck operations, allowing for a balanced management of mechanical, electrical, and hydraulic systems. This distribution helps in managing the immense physical forces at play during aircraft launches. Launching an aircraft from the deck of a carrier is a feat of precision engineering and coordination, all managed from the control hub within the bubble. This segment breaks down the complex process, showcasing the technology and teamwork that enable these massive ships to launch aircraft every 20 seconds. The sequence begins well before the aircraft is positioned on the catapult. Here's a step-by-step look at the initial preparations. Aircraft positioning. Aircraft handlers, guided by precise instructions from the bubble, direct the aircraft to its launch position on the catapult. This involves aligning the aircraft correctly with the catapult track to ensure a smooth launch. Catapult connection. The aircraft's nose gear is fitted with a T-bar attachment which links it to the catapult. This connection is crucial as it directly involves the catapult's mechanism, which will propel the aircraft at tremendous speeds. Once the aircraft is securely attached and all systems are verified ready, the real action begins. System energization. The central charging panel below deck energizes the catapult, preparing it for the launch. This involves loading the catapult's pistons or electromagnetic rails with the necessary energy to achieve the required thrust. Final checks. The bubble officer conducts a final series of checks, monitoring systems readouts and ensuring that all conditions are met for a safe launch. This includes verifying that the deck is clear and that the aircraft's engines are at optimal power. The culmination of these meticulous preparations is the launch sequence, a rapid and intense process. Engine power-up. The pilot brings the aircraft's engines to maximum power, creating the necessary thrust to support the catapult's force. This step is vital to ensure the aircraft can sustain itself in the air immediately after leaving the deck. Catapult activation. On a signal from the bubble, usually a green light or a thumbs up, the catapult is activated. This releases the stored energy, propelling the aircraft forward. Acceleration and release. The aircraft accelerates along the 300-foot track in under 2 seconds, reaching speeds of 160 knots, approximately 184 miles per hour. The holdback is released at the precise moment, freeing the aircraft from the catapult as it launches into the air. Even after the aircraft has left the deck, the role of the bubble and the ICCS continues. System reset. Immediately following a launch, the catapult system must be reset and prepared for the next launch. This involves recharging energy systems, clearing the track, and conducting a quick but thorough check to ensure all components are operational. Monitoring and feedback. The bubble monitors the success of the launch and gathers data on every aspect of the process. This information is used to tweak and improve future launches, ensuring continuous enhancement of safety and efficiency. The launch process on an aircraft carrier is a perfect blend of human expertise and technological prowess, all coordinated from the strategic vantage point of the bubble. This sophisticated orchestration not only showcases the capabilities of naval engineering, but also highlights the critical importance of each role within this process, from the deck handlers to the officers in the bubble, ensuring that every launch is executed flawlessly. Nimitz-class aircraft carriers represent a significant evolution in naval aviation technology and capability. These behemoths are equipped with the Integrated Catapult Control Station, known as the Bubble, which provides unparalleled control and oversight during flight operations. This segment explores the specialized features and strategic advantages of the Bubble on Nimitz-class carriers. Nimitz-class carriers are among the largest warships in the world, and their design incorporates advanced technologies that enhance their operational capabilities. Unique to Nimitz-class carriers, there are 2 bubbles positioned on the flight deck. The first is located on the starboard side between catapults 1 and 2, and the second is on the port side next to catapult number 4. This setup allows for simultaneous, independent control of different flight operations, increasing the efficiency and safety of aircraft launches. Unlike earlier carrier designs, the bubbles on Nimitz-class carriers can be retracted into the flight deck. This feature protects the control stations from environmental elements and potential damage during non-operational times or under harsh conditions. The design of the Nimitz-class carriers reflects a deep understanding of the needs of modern naval operations, offering enhanced flexibility and robustness. Redundant systems. The inclusion of dual bubbles ensures that operations can continue seamlessly, even if one is compromised or under maintenance. This redundancy is critical for maintaining the high operational tempo required during extended deployments. Strategic positioning. The strategic placement of the bubbles facilitates optimal control over flight operations. Officers in the bubbles have a clear line of sight to their respective catapults, improving communication and response times during critical operations. The advanced capabilities of the Nimitz-class carriers, particularly the features of the bubble, significantly impact the effectiveness of naval operations. The ability to control multiple catapults independently from 2 different bubbles increases the rate at which aircraft can be launched. This capability is vital during combat operations, where response time can be the difference between success and failure. The technology and strategic design of the bubbles also contribute to overall crew safety. By centralizing control and enhancing visibility, the risk of accidents during busy flight operations is significantly reduced. The Nimitz-class aircraft carriers, with their innovative design and advanced technological integration, represent the pinnacle of naval aviation capability. The bubbles, as central control hubs, play a pivotal role in these carriers, demonstrating how technology and strategic design come together to enhance the efficiency and safety of military operations. The unique features of these carriers underscore their importance in modern naval warfare, allowing them to project air power globally with unprecedented effectiveness. As we have explored in this video, the bubble, or Integrated Catapult Control Station, ICCS, is more than just a strategic vantage point on an aircraft carrier. It encapsulates the essence of modern naval operations, combining advanced technology, precise engineering, and critical human oversight. The efficiency, safety, and effectiveness of aircraft carrier operations hinge significantly on the functionality and reliability of the bubble. Looking forward, the role of the bubble in aircraft carrier operations is set to become even more crucial as the demands of global military engagements evolve. The integration of newer technologies, such as artificial intelligence and automated systems, into the bubble's operations could further enhance its efficiency and the safety of the crew. The ongoing development and upgrading of these systems will likely continue to set the standard for naval operations worldwide. We hope this deep dive into the heart of aircraft carrier operations has provided you with a clearer understanding of the crucial role played by the bubble. Its impact on the efficiency and safety of naval operations exemplifies the incredible capabilities of modern military technology and strategic design. Thank you for watching, and we invite you to share your thoughts and questions in the comments below. Don't forget to subscribe and hit the notification bell to stay updated with more fascinating explorations into military technology and operations. Join us in our next video to continue discovering the marvels of modern naval power.